If we want to find the limit of x times tangent inverse of x minus pi over 2 as x approaches infinity. As x approaches infinity, then we get infinity. And notice the tangent inverse of x. This is the graph for tangent inverse of x. So as x gets larger and larger and larger, the y approaches pi over 2. So as x gets larger and larger, y approaches pi over 2. And so this will go to pi over 2, and then minus pi over 2, which is 0. And so here we have infinity times 0, which is indeterminate form, which is indeterminate. But here we cannot apply L'Hopital's rule, since we don't have infinity over infinity or 0 over 0. So what we can do is multiplying by x here is the same as dividing by 1 over x. Multiplying by x is the same as dividing by 1 over x. And now as x approaches infinity, we get 0 down here. And so now we have 0 over 0, so we can apply L'Hopital's rule. And so to apply L'Hopital's rule, we need the derivative of the numerator and derivative of the denominator. The derivative of 1 over x. This is derivative of x to the negative 1, which is negative 1 times x to the negative 2, and is equal to negative 1 dividing by x squared. Derivative of tangent inverse of x is 1 over 1 plus x squared. Pi over 2 is a constant, so the derivative is 0. And so now the derivative of the numerator will be 1 over 1 plus x squared. Derivative of 1 over x is negative 1 over x squared. And this becomes 1 over 1 plus x squared times the reciprocal, which is negative x squared over 1. And so we have negative x squared dividing by x squared, by 1 plus x squared. And if we allow x to run to, as x approaches infinity, then we get a negative infinity over infinity. And so since we have infinity over infinity, we can apply L'Hopital's rule again. Derivative of negative x squared is negative 2x. Derivative of 1 plus x squared is 2x. Negative 2x divided by 2x is negative 1. Limit of the constant negative 1 is just negative 1. This is the answer.